Okay, guys, this is going to be a short and sweet video because we've only got a couple of things to go over in this particular section. One of the things that we want to make sure that we know is the area of the circle. Okay, now the area of a circle, most of you know, you've had this before, is pi r squared, where r is the radius of the circle. Don't confuse it with the circumference, which is pi d or pi, 2 pi r. So if we want to find the area of a circle, we need to know the diameter or the radius so that we can, or enough information to find that radius. So let's put a diameter in here of, let's call it 12. And let's say we want to find the area of this circle. So, excuse me, our area, write your formula, it really helps you focus. The area is pi. The radius here is 6, since the diameter is 12. So my answer is 36 pi, and that's the most exact answer that I can give because I haven't rounded off anything. 36 pi square units. Now, if the directions tell us to round to the nearest tenth or hundredth, we're going to put that in our calculator and work it out. Do not, I repeat, do not let the calculator replace your work. Keep showing your work. Well, you can let the calculator help your arithmetic, but you still need to show mathematically what you're doing. Okay, so I think you know very well how to do the area of the circle. What I do want us to look at, some of you may have had before and some of you may not have. So since I'm not certain about that, let me spend some time with you on finding the area of the sector of a circle. Now, a sector is a slice of the circle, just like if I take a slice of pie or a slice of pizza. The sector is bound by 2 radii and an arc piece of the circumference. So all this that I'm trying to shade in red is a sector. It's a piece of the area, just like when we found the length of the circumference, it was a piece of the circumference. So what is so great about that is we can use the same line of thinking to come up with the area of the sector that we use to find the length of a piece of the circumference. Remember when we found that a piece of a circumference, for instance, from here to here, let's say, I needed to know my central angle. And we said that x degrees, as the central angle, is to 360 as the length or the piece of the circumference was to the entire circumference. Well, this same ratio holds true for the area of our sector. The central angle is to 360 as the area of our sector is to the entire area of our circle. So A is to pi r squared as x is to 360 as L is to 2 pi r. Let's identify these variables. A is the area of a sector. R is the radius of the circle. X is the central angle in degrees. L is the length of the circumference of a piece of the circumference. Okay, and all this is a plug-in. Again, when you're plugging in, do not let your calculator replace your work. Now let me do a couple of examples with you in finding the area of the sector. Okay, let's start with a nice fresh circle. And in my circle, let's say that I have a central angle of, let's just say 27 degrees. And I have a radius of 9. And I want to find the area that is bound by the 2 radii and the arc. Okay, so I'm going to use my formula that the 27 degrees is to the entire 360 degrees as the area of my sector is to the area of the circle, which is pi r squared. So as I cross multiply this, I see that if I multiply these guys together and divide by 360, I'm going to have my area. If I want the exact area, I'm going to leave it in terms of pi. So let me do that first. I'm going to have 27. Now I'm using my calculator. It didn't replace my work, but it's helping me do the arithmetic. So when I do just the arithmetic part and leaving the pi out, I get 6.075 pi. That's the exact area, the very exact area, because I didn't use pi. But if I want to approximate, let's say they say, the directions say to the nearest hundredth, then I'm going to say the 27 times the 81 times, and I'm going to go to the pi button on my calculator, and I'm going to hit equal, and then I'm going to divide it by 360. And I'm going to get approximately 19.09 because I suggested the nearest hundredth. Okay, so we have an exact measure and we have an approximation. Let's do one more example. That was pretty sad, huh? Let's get that circle up there. Now then. Okay, so we have a circle. Let's put our center in here. And this time, I want all of this backspace. I want the area of all of that. And let's say my degree measure is 20. Now, if I want to, I can take the area of the whole circle and subtract out the little white sliver, and I'll know what's left. But I think I'm just going to do this a regular way, finding that backspace back there. I need to know my radius. We're going to say it's 5. So if this is 20 degrees, that means all the piece back there in my sector, change color there, it's going to be 360 minus 20. So my angle is a great big old 340 degrees out of the 360 degrees. That's in the same ratio or proportion as the area that I'm looking for is to the area of my whole circle, pi r squared. So now let's solve this thing for A. Okay, if I want the exact answer, I don't multiply in the pi, I leave the pi in the answer. We're going to round, let's round to the nearest thousandth. We haven't done that in a while. Let's round to the nearest thousandth. So 340 times 25 times pi equals, I'm going to divide that by 360, and that's going to be 74.176 when I round off, approximately. Okay? So don't let that throw you if you're going to get that back angle. That's perfectly fine. Also, there are some really interesting drawings that I've assigned for you. Do not freak out. Okay, just because something doesn't look like a spit in and spit out answer to begin with, don't let that bother you guys. You guys are honor students. You are, you're in here because you have the potential to think through it. So think through it. Think through those problems. If they don't come immediately, there's nothing wrong with that. You need to take some time and work on them. Don't run to your buddy to ask him help just because you looked at it one time and it didn't look pretty to you. You're selling yourself short when you do that. You guys can work any problem that I've given you. You just need to take the time and the focus to do it. I know you can do it. So hang in there. They're not going to be hard, but they're going to look a little different. That's okay. If you have any questions, anytime we're doing flipped, if you have any questions, write them down. You can email me, you can text them, or you can ask them in class the next day. That's what I'm there for the next day, is to answer your questions. So don't get, again, freaked out by the flipped idea. You can ask any questions you want to. This does not stop you from asking anything, and you can do any problem that's up there. So we're going to just stop. This is a short video, and when I see you Tuesday, you're going to work the circles and segments, not segments, sectors problems in class. I mentioned segments because I was going to show you. Let's see. I'm going to show you what a segment of a circle is. A segment of a circle is bound by a chord and an arc, but we're not going to worry with those this time. Okay, so I know you can do this. You've got this. Review this if you need to. And I'll see you Tuesday, and we'll work these circle and sector problems together. These are really important circles, sectors all over ACT. We've got this. Okay? Have a good weekend.